Hi, welcome to the introduction of a channel that I am calling Euclid's Elements. My name is Dr. Leroy Alloways. I have a PhD in mechanical engineering, but I graduated with a Bachelor's of Arts in Applied Mathematics, graduated #1 in my class from California State University, Chico, and I had a great love affair in mathematics. However, I got my PhD in engineering, and while I was doing my research on my PhD, I found this old book. This was found about 30 years ago. Back then it still had a little cover on the spine, but I've opened it up quite a few times. And the title of the book is The Elements of Geometry. It contains the first 6 books of Euclid. And when I opened it up, I saw these wonderful theorems and propositions in it, and I just loved it. And the cool thing about it is all the theorems and proofs and so on, you can solve them using the simple tools of a compass, a straight edge, and a pencil. Those are only the three things that you need to solve these problems. And you can solve every single one of them with those 3 tools right there. And there are hundreds of them. Book 1, there's 6 books in there. Book 1 alone has 77 different propositions in it, and all of them are solved. Now, I'm going to solve them using those 4 tools, but I'm going to add 2 more. I'm going to add you can barely see it here, I'm going to add a triangle. This is a 30, 60, 90 triangle. And the reason why I'm going to add triangle is because it's just going to save me a little time, and I don't have to reconstruct a 90-degree angle all the time. I don't have to reconstruct a 60-degree angle all the time. And 2,000 years ago, I can probably guess that Euclid had created some form of triangle, or definitely some form of right angle, some form of device for that. And I'm also going to add one other one. It doesn't matter much, and it's just a pair of dividers. A pair of dividers is like a compass, except for the pair of dividers doesn't have a piece of lead on it. And the cool thing with a pair of dividers is I can open and close them quicker than I can with this. This has locks and everything else on it, but it's for quick measuring or quick comparing of measurements outside of using a ruler. And I'm considering this, I'm calling this my straight edge. So I'm going to solve all the problems in this book with just this materials, and I'm going to follow it. I'm going to follow the proofs the way the book does the proofs. And now let me tell you about the book. And first off, I want to read the preface. And if I read the preface, you'll understand why I think this book is really, really cool. And so the preface starts off as, "It is a remarkable fact in the history of science that the oldest book of elementary geometry is still considered as the best, and that the writings of Euclid at the distance of 2,000 years ago continue to form the most approved instruction to the mathematical sciences." Now, I'm going to pause just for a moment. This book right here is an 1855 reproduction of a book that was printed printed in England in 1813. Okay, the book is written by John Playfair, and John Playfair was a mathematician at the university, or a professor at the University of Edinburgh. And so he's writing this, and I have to say, as I read this, he's very long-winded when it comes to sentences, uses very big words, and he writes it in Old English style here and there. It's like, well, why did he say it that way? But I'm going to read it the way he wrote it, because it's kind of cool. And he's going to mention a professor, and I'm going to get into him too. He's going to get into a professor, and that professor is Robert Simson. And I will talk about Robert Simson and the importance of Robert Simson and the importance of his words. So let me go on. The remarkable distinction the Greek geometer, Euclid, owes not only to the elegance and correctness of his demonstrations, but to an arrangement most happily contrived for the purpose of instruction, advantages which, when they reach a certain eminence, secure the work of an author against the injuries of time more effectively than even originality of invention. Okay, so if you do it right, you can't destroy it. That's really what he's talking about. The elements of Euclid, however, in passing through the hands of the ancient editors during the decline of science, have suffered some diminutions of their excellence, and much skill and learning has been employed by the modern mathematicians to deliver them from blemishes which certainly did not enter into their original composition. Okay. The question here is, who are the modern mathematicians? Okay. Now, this book is 1855, originally published around 1813. Okay. Originally published by a guy named Robert Simson. Actually, I have to take that back. Simson finished the book in 1756. That's when Simson finished the book, and so who is he talking about when he talks about the modern mathematicians compared to the ancient mathematicians? And why does he have to defend against the modern mathematicians, or the excellence of the modern mathematicians? And I will tell you, one of the modern mathematicians was, when Simson graduated college in 1701, Isaac Newton was still alive. Of these mathematicians, Dr. Simson, as he may be accounted the last who has been the most successful. Now, what he's talking about is the mathematicians who are trying to reproduce Euclid's work, or defend Euclid's work, or show what Euclid's work was about. And was most successful, and has left very little room for the ingenuity of future editors to be exercised in, either by amending the text of Euclid, or by improving the translations from it. Such being the merits of Dr. Simson's edition, and the reception it has met with, having been every way suitable, the work now offered to the public will perhaps appear unnecessary. And indeed, if the geometer just named, Dr. Simson, had written with a view of accommodating the elements of Euclid to the present state of the mathematical science, it is not likely that anything new in elementary geometry would have been soon attempted. But his design was different. It was his object to restore the writings of Euclid to their original perfection, and to give them to the modern Europe as nearly as possible in a state wherein they made their first appearance in ancient Greece. For this undertaking, nobody could be better qualified than Dr. Simson, who, to an accurate knowledge of the learned languages and an indefatigable spirit of research, indefatigable means tirelessly, spirit of research, added a profound skill in the ancient geometry and an admiration of its most enthusiastic. Again, you gotta love Old English. Accordingly, he not only restored the text of Euclid, wherein it had been corrupted, but in some cases removed imperfections that probably belonged to the original work. Through his extreme partiality for his author, partiality to Euclid, never permitted him to suppose that such honor could fall to the share either of himself or to any of the moderns. But after all this was accomplished, something still remained to be done, since notwithstanding the acknowledged excellence of Euclid's elements, it could not be doubted that some alterations might be made that would accommodate them better to a state of the mathematical science, so much more improved and extended than at the period when they were written. Accordingly, the object of the edition now offered to the public is not so much to give the writings of Euclid the form which they originally had, as that which may be present rendered them most useful. Now, that's just part of the preface. It goes on and on, talks about some of the changes. So it's an amazing book. Amazing. The author, Playfair, was an amazing mathematician. But I want to talk a little bit about Simson and who we have here. Again, he graduated from the University of Glasgow in 1701, and his advisor was Edmund Halley, i.e. Halley's Comet. And Halley's, just to put you in a little context here of what we're talking about, moderns. So Simson's advisor was Edmund Halley, Halley's Comet. And one of the other of his advisors was James Jurin. Now Jurin was the secretary of the Academy, Royal Academy of Science, something very prestige to get in. But James Jurin's advisor was Isaac Newton. So Simson was not that far away from Newton, and in fact, again, when Simson graduated in 1701, Newton was still alive and kicking and doing well at Cambridge. So those are some of his contemporaries. Now, one of Simson's students is a guy named Colin Maclaurin. Now, the fascinating thing with Colin Maclaurin is he was the youngest, I believe he might still be, the youngest full professor ever. And if you took calculus and you remember series, you'll remember the Maclaurin series. So Simson was not a B-rated player when it came to the mathematical world. Simson was up there. He was on the A team. Now, the interesting thing is, after Simson graduated in 1701, he went directly into the church, but he was still doing mathematics and he's still advising, and he started working on the work of Euclid, and he originally published it in Latin, and then he converted that, they translated it into English. And if you go down below Simson a little bit, what we see is, Simson had a couple students, one named couple named Stewart, and down 3 levels below Simson is John Playfair, the guy who wrote this book. Okay? Playfair, if you go down below Playfair 3 students, you actually run into James Clerk Maxwell of Maxwell equations. And so it's a very prestigious line of mathematicians. Now, the fascinating thing is, if you go down from Maxwell, you go down to, he had a student named Crystal, who had a student named Waterburn, who had a student named Jacobson, who had a student named Charles Curtis. Curtis, he was a professor at the University of Oregon, and he did algebra, ring theory, group theory, and these are the things that I think are my strongest. If I would have gone to the University of Oregon, I would have just zoomed right over towards Curtis. But the fascinating thing about that is Curtis had a student named Bill Fisher. Well, Bill Fisher was my advisor, or was one of my mathematical advisors when I was an undergraduate. And Fisher taught me logic. I mean, really logic, good logic. He taught me ring theory, group theory. He taught me transformational geometry. Fisher's contemporary, Robin Soloway, taught me plane geometry. And all of those are the fundamental logic courses that you build upon when you're a mathematician. And except for ring theory and group theory, those are what we call modern algebra. And I consider myself really more of an algebraist than a geometer, but I love geometry. I see geometry. Fisher and Soloway were both just blown away that I would walk over and just do something in the geometric world, and they're going, "How do you see that? How do you know that?" And I just know that, and it's obvious. But that's one of the reasons why I got this book, is I love this book. And as an engineer, mechanical engineer, this is one of my original mechanical engineering tools when I was an undergraduate, at the same time in mechanical engineering as I was in mathematics. So this is a cool book. This is a cool project I've been wanting to do for a long time, is to actually work my way through every single proposition. And so what I'm going to do is I'm going to make a video on each one, and I might make a short. I've already posted a short on the very first one, but I'm going to redo the first one. And on this particular page, there's going to be, my first comments on this page are things that are necessary for this project, and that is the original elements, or the original principles that are written in this book. And the principles I will give one right here, the very first one. Principle number 1 in book 1 is geometry is a science which has for its object a measurement of magnitudes. Magnitudes may be considered under 3 dimensionals: length, breadth, height, or thickness. Now, again, everything's written in English, so Old English, and so the terms that we would use are length, width, and thickness instead of breadth. So I'm going to post these in the original wording down in the first comment. There's also other things that need to be posted down there. For example, the definitions used and the postulates and the axioms. The axioms of Euclid are things that are, some of them are quite obvious. For example, number 2 on the list, if equals be added to equals, the wholes are equal. That's typically algebra. If you add something to one side of the equation, add it to the other side of the equation. So, and maintain that equal sign in the middle. So this is the undertaking that I'm going to be doing. If you like this channel, please like it. Please subscribe. Give me comments. Give me comments on what you think about it. I'd really appreciate that. And this is going to be a fun ride. Thank you. Bye.